So we want to make a class to represent coordinate points. In other words, every object of this class should represent a coordinate point. Now, what does a coordinate point have? Well, it has, every coordinate point has we will use integers, an int x and a y, an x value and a y value. We could maybe use doubles instead, but I decided to use ints here. Now, if we want to create a coordinate point, you can say coordinate point p1 equals new coordinate point, but we want to be able to initialize the x and y. So we want to be able to say maybe, 8, -2, right? So that would be a coordinate point at location 8, meaning x value 8 and y value -2. So to make this work, we'll write a constructor in the coordinate point class. And here it is. So public coordinate point. Okay, so notice the name of the constructor is the same as the name of the class. And a constructor does not have a return type. And we'll have parameters here for the initial x and initial y. So in initial x and in initial y. And then we'll take these initial x and y, these two parameters, and assign them to the appropriate field. So we'll say x, the x field should be assigned the initial value of x, and the y field should be assigned the initial value of y. All right, so now we are able to create our point here, and now we want to be able to print out the point. Okay, so in order to do that, we want to say no, hold on. Okay. All right, so I want to be able to say, P1, let's say, well, let's start even simpler. Let's say I want to just get the x value. I want to print out the x value. All right, now I don't have such a method yet, so I'll have to write it. If x would be public, if x and y will be public, then I could just say p1.x, right, to print out x, and that would print out in this case 8. But I don't want to make a public. Fields usually are private. So fields usually should be private, and so we want to have a getX method for getting the value of x. So we'll write it pretty simple. So public int getX, and all it does is it returns the value of x. Now, importantly, I can have multiple coordinate points, and each coordinate point can have a different x value and different y value. Right, let me just also write public int get y. It returns the y value. So let me go here and print. When I want to print out a point, I'll print out open parentheses plus the x value, and then plus a comma plus hold on. Okay, plus a comma, plus the x value, sorry, the y value, and plus a closing comma, closing parentheses. Now, of course, this is all very annoying to have to do all this. So let's actually instead maybe write a method named Twostring, and pretty much every class that we write will want to write a Twostring method in that class. So public, so it's going to return a string, and it's going to give me a string representation of an object. So public string to string, that's the standard name for such a method in Java. And it will return, so exactly what we had, right? Exactly what we want, right? So the opening parenthesis plus the x value plus a comma and a space plus the y value plus a closing parenthesis. Sorry, closing parenthesis. Now notice here we are able to access x and y directly because we are inside the coordinate point class right now, right? This method is in the coordinate point class, so it has access to the fields directly. It doesn't need to call any methods to do that. Okay. So now I will simply say here, when I want to print out a point, I'll say p1 dot to string. Oops. Okay, and that's great. And now if I want to make another coordinate point, let's see how I'll do that. See how I'll do that. So I can make another coordinate point. Not comparable. Nope, not that. Okay, I can make another coordinate point. P2 equals new coordinate point, and I need to give it initial x, initial y. Let's say 7 and 3. Okay, so and now I can go ahead and print out p2.toString. Okay, so let's see what we have here. So let me open a new terminal. So just the point here is that each coordinate point object can have a can have a different x value than every other point and a different y value than every other point. All right, so we can do Java C test coordinate point.java, and when I tell Java to compile test coordinate point.java, Java will also compile coordinate point.java because test coordinate point relies on coordinate point. In other words, you cannot have the test coordinate point class without the coordinate point class because the test coordinate point uses coordinate point. It says explicitly, for example, coordinate point P1 and so on. So, so by telling Java to compile test coordinate point, we're also going to compile coordinate point. Let's see. All right, now if we do ls, we see we have our coordinate point dot class. That's the bytecode for the coordinate point. Coordinate point.java, that's what we wrote. Test coordinate point dot class and test coordinate point dot java. Okay, let's run. So now to run this, we'll say the name of the class that contains the main method that we want to run. All right, so if I try running coordinate point, I'm going to get an error because there's no main method in coordinate point. Right, so if I want to run a program, it needs to have a main method. So what I want to run is test coordinate point, and I get 8, -2 for P1, and then I have 7, 3 for P2. So it seems to work well. Okay, now suppose I want to also be able to create a coordinate point without specifying the initial x and y value. So I want to be able to say coordinate point P3 equals new coordinate point, and just not have to provide any inputs to the constructor. And I want to just give it a default value of 0 for x and y. There's a question here whether I have to say the words initial x. I did not type this. I did not type initial x. For some reason, the IDE is inserting it. I can get rid of it. But whatever. The point is, I did not type initial x. I just typed 7 and 3. So Many IDEs have this where they put in these words just to clarify what these arguments are. Okay, so right now line 9 will not work. You see that I'm getting this issue here. It says the constructor coordinate point with no parameters is undefined. Okay, so what I want to write is a no arg constructor. Okay, so I'll say, and the order of these things doesn't matter, but I'll just put it on top here. So I want to say x should be assigned the value of 0 and y should be assigned the value of 0. I could give it a different default value. If I want to say I can give default value of 3 and 7, whatever, I could do that. And then, right, so what's going to happen then? Right, so if I now go ahead and go and print p3 dot toString, let's recompile and rerun. So Java C test coordinate point.java and Java test coordinate point. Okay. All right, so I see now for P3, I have 3,7. Why is that? Well, I created it by calling the no arg constructor. Okay, this is a no arg constructor. There are no parameters. And this constructor just says x to 3 and y to 7. Now, this is not a particularly reasonable thing for this constructor to do, right? If I'm creating a coordinate point without specifying inputs, probably I just want it to be 0, 0 or something like that. Probably. I mean, you know, so anyways, I think it makes more sense to just make x equals 0 and y equals 0 in this case. And if we go ahead and recompile and rerun, we have 0, 0 for P3. Okay, so that's good. All right, so now let's add another method. Let's add, so we have getter methods. Okay, get x and get y. Now we'll write a setter method. So we can write separate methods for set x and set y. I thought maybe let's write a just one method that will be able to set x and y at the same time. So let's say public void set location. So we'll set the location of this coordinate point, and we'll say, and of course, when we have parameters where the user tells us the x location and the y location, so int x location and int y location. Okay, and what we're going to do is we're going to say x should be assigned an x location, whatever the x location was from the parameter list, and the y should be assigned the y location from the parameters. So now if I have a point like P2, which initially is at 7,3, I can now go ahead and say P2.setLocation and give it a new location. So I can make it be at, let's say 5, I don't know, -2. Well, let's make it -1. Okay, and now if I print out P2, I'll get, let's see. So let me actually add some things here. So let me say P1. Okay, and 2. And I'll say now P2 is okay, and we have P3. Okay, so let's recompile and rerun. All right, so now so what do we have? We have hold on, go. Yeah. Try again. Okay, so P1 is 8, -2, 8, -2, P2, 7, 3, and now P2 is 5, -1. Right, so we set the location to a new value, and that's pretty, pretty typical. You set the point to a certain value, but then it moves. You want to move it somewhere else. And then P3 is 0, 0. Okay. So now let's now talk about this. So let's see. Okay, so now we have to talk about this keyword. So whenever we call any of these methods that we wrote here, right? Get x, get y, toString, set location, we are calling it using an object of the class. Right? So when I want to call toString, I can't just say toString. I can't just say, toString, because toString of which object, right? I want a string representation of which object. And I cannot just say CoordinatePoint.toString. That won't either work, because it doesn't make sense. Well, it doesn't make sense to ask the class to give me a string representation, because I don't want a string representation of the class. I want a string representation of a particular point object. Okay. Okay. So now again, so whenever every method that we've written so far operates on a particular object, right? So whenever we call the method, we're calling it to operate on a specific object. So the thing is that every method, well, except for static methods, which we haven't yet seen, so every instance method has this special reference named this, and what this refers to is the object that calls the method. So, for example, in the toString method, when I'm saying x here, what I really mean is this.x. So what is this? Right. So what is this? Well, when I call toString, I'm calling it using a reference variable like P1. P1 refers to an object. So when I say P1.toString, and I'm going here to the toString method, this, right, this reference refers to the object that P1 refers to. Again, I'm using P1 to call the toString method. P1 refers to an object, and what I would like to know is I would like a string representation of that object that P1 refers to. Now, inside the toString method, this will refer to the object that P1 refers to. So it's like a copy of P1. So it's like I'm saying, P1.x, except I don't want to say P1.x, because I'm not just calling toString with P1. I can also call toString with P2. So when I say P2.toString, then this refers to the object that P2 refers to. Again, P2 refers to an object. I would like a string representation of that object. Well, inside the toString method, this refers to the same object that P2 refers to. Now, when I go ahead and say P3.toString, okay, so I would like a string representation of the object that P3 refers to. Then inside the toString method, this refers to the object that P3 refers to. Okay, so so the point is this refers to the object that is calling the method. Okay, and I can say this.y. Now I don't really need to say this.x and this.y. I can just use x and y, because when I say x and y by themselves, Java usually understands that I mean the fields. But now, when would there be an issue where Java does not understand that I mean the field. So let's say I had a local variable inside this method for some reason. I'll int x equals 10. Okay, it's a stupid thing. No reason for this variable. However, look what's going to happen now. Let's go back here. Okay, let's recompile and rerun. Okay, notice all the x for somehow all the two, every time we call toString, it's printing 10 as the x coordinate. 10 comma -2, even though we made it 8 -2. And instead of 7 comma 3, it's printing 10 comma 3, and so on. It's printing 10 for all the x values. So why is that? Well, when you have a local variable in a method that happens to have the same name as a field, right? So we have a local variable, x, and we also have a field, x. So when on the next line, when I say x to give me the x coordinate and put it in the string and return that string, well, when I say this x, what do I mean? Do I mean this variable x, which has a value of 10? Or do I mean the field, which can have, 7 or 3, whatever, depending on whatever I assigned for the x coordinate of the object? So the answer is that by default, Java understands x to just mean the local variable. So if I want to instead refer to the field, I want to indicate the field, I have to say this.x. Okay, so now I recompile and run. So now I get the correct x values, right? I don't get the 10 anymore. Now, of course, this line is a stupid line. I wouldn't do this in a normal case. There's no reason to have this x value. In fact, my IDE is warning me the value of the local variable x is not used. So it's kind of saying, why are you making this variable? You never use it, right? So this would be pretty stupid to do, but but there are many cases where I do want to use the this keyword, right? So again, this particular method is really no reason to use the this keyword. However, let's look at the set location method. Let's say I rename these parameters to be x and y, right? I don't need such long names. X is a tells me enough information, right? Whenever you name variables, you want the variables to tell you something. You don't just want to name them, you don't just want to name them x if they indicate like a price of something, right? If it indicate a price, you want to name the variable price, for example. But in this case, x is a perfectly a name that makes perfect sense. It's the it's the x coordinate, and this y is the y coordinate. So it makes sense to just name these variables y. But if I'll say x equals x and y equals y, that's not going to actually be doing what I want it to do. Let me show you. So again, back to test coordinate. So let's go here. Okay, so we have P1, we don't need that right now. P2, okay, so we initialize P2 with 7 comma 3. Okay, so we see P2 is 7 comma 3. And then we said P2.setLocation 5 comma -1. But look what happens. For some reason, P2 is still 7 comma 3. It was never changed to 5 comma -1. So what happened there? Well, remember when I say x or I say y, since I have a local variable named x, right? This parameter is a local variable. It's a variable that's local to this method. Okay, and so I have a local variable named x and I have a field named x. So when I say x, Java understands me to mean the local variable. So what is this line doing? It's saying, take the value of this local variable x and assign it to the local variable x, which is kind of a stupid thing to do. It doesn't accomplish anything. It just takes the value of x and puts it into itself. But it doesn't do anything to the field, right? It doesn't do anything to this field because when I say x, just plain x, Java understands that to mean the local variable x. and this is a local variable. In fact, my IDE is warning me. It's saying the assignment to variable x has no effect. Okay, so here is where this keyword comes in very handy. So this dot x equals x. So what does that mean? That means x is the local variable, this parameter. Take that local variable and assign it to this dot x. Okay, this dot x means the x field of the object that is calling the setLocation method. Right. So when I call this p2, so p2 refers to some object, and in the setLocation method, this refers to the same object that p2 refers to. So this dot x equals x, this dot y equals y. Now let us recompile and rerun. All right, so now we see the update has been done successfully, right? After we say p2 that's setLocation, now we have p2 is 5, -1. All right, let's go back now to the constructor. So for the constructor as well, instead of naming these parameters initial x and initial y, maybe I'll just name them x and y. Okay, so I can't say initial x, I have to say x and y. Okay, but now I have the same problem as before, where when I'm saying x equals x, that's just assigning the value of this local variable to itself. It's not actually assigning anything to the field. So again, the solution is this dot. Okay, great. Now, of course, here as well, I could say this dot x equals 0, but it's not necessary because in this constructor, I don't have a local variable named x. Again, in this constructor, I do have a local variable named x. It's this parameter right here. It's a local variable. It's a variable that's local to this method. So if I just say x by itself inside this constructor, it just indicates the parameter, the local variable. So that's why I need to use this dot if I want to indicate the field. On the other hand, this constructor has no local variable named x. You could have other local variables, perhaps. Maybe I'll have int z equals 10, but that doesn't matter. That's not the same name as any of the fields. So there's no need to use this dot x. Okay, but of course I could say this dot x and it'll work just fine. All right, let's now talk about another use of the this keyword. Okay, so another use of this keyword is for one constructor to call another constructor. So it's very common for a class to have multiple constructors. For example, this class has 2 constructors, but in general, a class can have maybe 10 constructors. And it's very, very, very common that they all pretty much do the same kind of thing, but in a slightly different way, or initializing variables in to slightly different values, somewhat different values. So it's pretty common for constructors to all kind of do the same kind of thing. And so in this case, we notice that this constructor here assigns values to x and y, and this constructor also assigns values to x and y. Right? They both basically do the same thing. This constructor, though, assigns given values, right? So we need to have these parameters x and y, which it assigns to the fields x and y. And this other constructor just always assigns 0 to the fields. But there is kind of a duplication of code. Even it's not quite duplication, but we have these 2 lines which are pretty similar in two constructors, and we prefer not to have to repeat ourselves. We're not really repeating ourselves because these 2 lines are not exactly identical to these 2 lines, but they're similar enough, and we'd like to get away with not having to write them out. So what we want to do is have we want this constructor should call the other constructor and send it 0 and 0 as arguments, right? And then this other constructor will initialize the x, this dot x to 0 and this dot y to 0. So how can we do this? So here we have the second use of the this keyword, right? So until now we were saying this dot x, and we're still going to continue doing that. But now we have an additional use of the this keyword, and that's the this keyword followed by parentheses. This followed by parentheses. And what that means is call another constructor of this class. Okay, so in this case, we will say this 0, 0. Okay, and so what that's going to do is pass 0 and 0 to this constructor. So 0 is going to be x and 0 is going to be y, and then this constructor will take the x local variable, right, the parameter x, and assign it to this dot x, and it will take this local variable y and assign it to this dot y. Okay, let's just test this to make sure it works. All right, so we see that everything works the same as before, including when we say when we create P3 to without specifying anything in the parameters, and we print out P3, we see we get 0, 0. That looks good. Okay. Let's see. So let's go ahead and write some other methods in this class. So let's say, well, actually, let's actually, before other methods, let's do a copy constructor. So let's say I want to make a new coordinate point. P4 equals new. Well, I want it to be a copy of, I don't know, P2. Okay, I want P4 to be a copy of P2. So one way you might say is coordinate point P4 equals P2, right? How do if I have you know, int a equals 10, and I want b to be an int that's a copy of a. How do I do that? I say int b equals a, right? So that you know that works for primitive values, primitive variables. Let's try to do the same thing for P4, right? For a coordinate point. So P4 should be a copy of P2. Okay. So let's see. So you know it would seem to work. So if we print out, if we go ahead and print out P4, all right, we will see that it's going to be a copy of P2. Okay, so we see that P2, well, we initially said 3, and then we said P2 is 5, -1, and we see indeed P4 is also 5, -1. So that looks good. However, look what happens if we modify P4 or if we modify P2, right? So if I say P4 dot set location and I give it a new location, I would say 10, 10. Okay, and then I go ahead and print out. Let's say go ahead and print out P2 and P4 now. So P4 is obviously going to now be 10, 10. But how about P2? Okay, so P2, let's see. All right, so we see that P2 has also been modified to 10, 10. Okay, now that's not really what we usually want. So what we usually want is that P4 should refer to a completely independent object, so that if I modify P4, if I say P4.setLocation 1010, that should not have an effect on the original object. Right. So what I really want is, so what I was doing here was I was just making a reference copy. I was just making a copy of the reference. So now P4 refers to the same object that P2 refers to. So when I use P4 to set location, I am modifying that's the same object that P2 refers to, right? When I say P4.set location, I am modifying an object. But which object? Well, I'm modifying the object that P4 refers to, but that's the same object that P2 refers to, because P4 is a reference copy of P2. Okay, so that's not quite what I want, right? Usually I want to have P4 be a completely independent object that happens to be a copy of P2. But if I would go ahead and modify P4, that shouldn't have an effect on P2. So here's one way to do this. I can say coordinate point P4 equals, well, I want to create a new object equals new coordinate point. And I want to initialize it to be a copy of P2. So I can say P2 dot get x and P2 dot get y. So what's that going to do? Well, it's going to grab the values of x, of P2's x and P2's y, send them to the constructor of coordinate point, and that's going to initialize the x and y coordinates for the new object. So that works, but it's a little cumbersome to have to say P2.getX and P2.getY and send them to the constructor. What I really want to do is just say this, right? Coordinate point P4 equals new coordinate point of P2, meaning it should be a copy of P2. I want to make a new I want P4 to refer to a new coordinate point object, completely new object that should be initialized as a copy of P2. So, well, how can we do this? So for this, in order for this to work, we have to write a copy constructor. So we're going to do public coordinate point. So first of all, this is a constructor. So no return type. What we're going to do is so we're going to have a parameter, so the type of the parameter is going to be a coordinate point. And this is going to be the original object, okay? And it's going to refer to the original object. And now I want to create a new object that's a copy of the original object. So in other words, I want this dot x to be assigned the original dot x. Okay. And I also want this dot y to be assigned the original dot y. Okay. So now let's try doing this again, right? So now let's go ahead and print out P4. So what do we expect to see? Well, we expect to see that P4 should be a copy of P2. If P2 is 5, -1, then P4 should also be 5, -1. So let's make sure that works. All right, so we have P4 is 5, -1, so that's great. Now, when I say P4.setLocation 10, 10, so now we see that P4 is 10, 10. However, notice that P2 is still 5, -1. All right, so modifying P4 does not have an effect on P2 because P4 refers to a completely different object than P2 refers to. So that's good. Okay. So let's write another method. So let's say I want to know the distance between a point and another point. So I want to know double distance I want it to be, let's say, I want to know the distance from P1 to, so let's say P1.distance to, let's say 5, 7. So I want to know the distance from P1 to 5, 7. Okay, so of course I need to write a method to do this. So public double distance to, and it's going to take an int x and an int y. So I want to know the distance from this point to the given x and y. what do I mean? What do I mean by this point? Again, I want to know the distance from this point to the given x and y point. So what's this point? Well, this point is the point that's calling the distance to method. In this case, it would be P1, but I can also say, P4 dot distance to, let's say 4, 4,1, right? So maybe I want to know the distance from P4 to 4,1. So the point is, whenever I call distance to, I'm calling it using a particular object. So that's what I mean by this point. When I say this point, I mean the object that calls, that is currently calling the distance to method. Okay, so so how do we find the distance from this point to this other point? Okay, so there's a formula for this. What we do is we find the delta x, right? So the difference in x, and that's going to be this dot x minus this parameter x. Again, here I need to be able to differentiate between the field of this point and the parameter, which is also named x, but I differentiate them by using this dot x for the field and then just x for the parameter. So that's the difference in the x values between this point and this other point. How about the difference in y values? So that, no, I'll call that delta y. Delta is a term that generally means difference, right? You've seen it probably in your math classes, some of your math classes. So this dot y minus y. Okay, and then I need to take each of these and square them. Okay, so I'll do math dot power. So delta x to the power of 2. Okay, I need to add that together with delta y also squared. And now I need to find the square root of this sum. All right, so math dot square root of this. Okay, and then I simply want to return this result. So return math dot square root of math dot power x delta x squared and delta y squared. All right, so let's test this. So the P1 is at 8, -2. And we want to know distance to 5, 7. So we want to know the distance from 8, -2 to 5, 7. All right, so let's go ahead and print it out. Plus this distance that we found on the previous line. Okay, so we say that it is 9.86, whatever, 486 something. Let's try to check that. Let's see if we can use Google to just verify that. Let's try Wolfram Alpha. All right, so 9.486, whatever. So that looks about right. Meaning, so it looks like we got the right answer here. Okay, great. Let's see, what else can we do? So let's say we have 2 coordinate points and we want to test them to see if they're equal, right? So if I have, so let's say, I don't know, we have P4 is 10, 10. So let's say we have coordinate point P5 equals new coordinate point, and we'll make it 10, 10. Okay. So what happens if I say, P5 equals, well, yeah, what did I say? P4 equals P5. Okay, so let's see. So P4, when I printed it out, it's 10, 10. And P5 is also represents 10, 10. So is it true that P4 equals P5? So the answer is that no, this is actually false, because P4 refers to a different object that P5 refers to. And when I use equals to compare two reference variables, right? P4 and P5 are reference variables. So when I use equals to compare reference variables, Java compares the addresses that they are storing, not the contents of the objects that they refer to. Right? So P4 refers to an object, P5 refers to an object, but Java doesn't look at the contents of those objects when I say P4 equals P5. It just looks whether they're the same object. Basically, does P4 refer to exactly the same object that P5 refers to? And here they don't. They refer to 2 objects that are equal to each other, but they don't refer to exactly the same object. So this is false. So what I would like to have a way of doing is saying P4 dot is equal to P5, and I want that to be true. Okay, so let's write that method. And the parameter of this method is going to be a coordinate point, or other. And how do I tell if a point is equal to other? Remember, when I call a method like is equal to, I'm calling it using an object. I'm calling it on an object. In other words, in this case, I'm calling it on P4. Right. So when I say this inside this method, it refers to the object that P4 refers to. And other refers to the object that P5 refers to. So in other words, I want to know, is this .x equal to other .x? And I also need to make sure that, because that's not enough, just because the x values are the same doesn't mean the points are equal to each other. I also need to make sure that the y values are the same. So this .y equals other .y. And of course, this entire thing is going to turn out to either be true or false. And whatever result that is, I just want to return it. Okay, now, technically, I don't need to say this .x. I could just say x. I can just say y, because I don't have a local variable named x, right? I have other .x, but that's not a local variable, because x is not a variable here. I'm using, right? I never said, int x equals whatever. That would be a local variable. Or if I have a parameter named x, that would be a local variable. But I don't have a local variable named x. So I really don't need to say this .x. But I think it works. I think it's nice to say it because it makes it clearer, I think. Okay, so let's try and test this. So I say that this should be true. But let's verify that. All right, so we see this last line is true. So that's great. Okay. Now I think we'll come back to this CoordinatePoint class, but I think we should first talk about static fields and static methods. So let's make a new file called Reservation, and every object of the reservation class represents a reservation that someone makes for a room for a particular day. Right, so we'll have, maybe I'll actually rename this, hold on. Name it to test reservation. Okay, so, and I'll have a main method here. Now I can actually write the reservation class in this file. So class reservation. Just a little note here. You're allowed to have multiple classes in one file. In many cases, it's not considered good style, so I won't encourage you to do it usually. But you could technically have multiple classes in one file. But when you do that, you cannot have multiple public classes in one file. Right? So if you have a public class, there can only be one of them. And if you have a public class, it should have the same name as the name of the file. Test reservation. And then you can have additional classes here. So here we'll have a reservation class. And we typically name the, in a case like this, right, where we have multiple classes in one file, we will use the class that has the main method to be the name of the file, to be the public class and therefore the name of the file. Okay, so here, we might want to say reservation R1 equals new reservation, and well, I want to initialize it to represent the reservation for a particular room. So maybe 4141 I, and for a particular day. Okay, so we're gonna use numbers to represent days of the week, right? So so we'll have 0 representing Sunday, 1 representing Monday, and so on. So for Monday, we'll put a 1. And so that's what we want to do here. So we're going to have a class reservation. It's going to have private string. It's going to be the root, tell us the room. And we'll also have a private int day of week. Okay. All right, then let's write our constructor. So it's going to take the room number, the room and the int for day of week. And of course, it's going to say typical this dot room, and assign it to room, and this dot day of week is going to be assigned to day of week. Okay. Nothing interesting there. Now, suppose we want to keep track of the number of reservations. Okay, so we want to have a field to keep track of the number of reservations. It's going to be an integer. Okay, and now, of course, we can make many reservations. So we can say reservation R2 equals new reservation, and maybe it will be in a different room, maybe 1300 B, and the day of week maybe is 3. Okay, so that's another possibility. So the point is, I can make many reservation objects, and each one can have a different room number from each other, and each one can have a different day of the week from each other. Okay, they don't have to share the same value. On the other hand, num reservations is not unique to each object. right? The number of reservations, when I talk about R1, the number of reservations is not specific to R1. The number of reservations is a class-wide issue, class-wide thing to consider. How many objects of this class have we created? How many reservations have been made? It's not. It does not have to do with any particular object. It's not unique to each object, right? We don't need each object to have a copy of num reservations. So in this case, we will make it a static field. Now, we'll initialize num reservations to be 0, meaning at the beginning of the program, the value of num reservations is going to be 0 because at the beginning of the program, no reservations have been made so far. But now in the constructor, every time we call the constructor, we're creating a new reservation. So we need to do num reservations plus. Let's make a method here to give us the num reservations. So let's make a public int get num reservations. And so it's going to return num reservations. So that works. So I can say, you know, I can say, let's say R2 dot get num reservations. So what is it gonna print here? How about here? So I just say so what's going to be printed here on line 4? R1 that get num reservations. It's going to be 1. How about when I say here R1 that get num reservations? Well, now it's going to be 2 because now two reservation objects have been created. In other words, this line has been run twice, right? Every time we call the constructor, this line runs, and the constructor has been called twice. First here, and then right on line 3, and then on line 4. Sorry, on line 5 rather. So here on line 6, when we ask for num reservations, it's going to be 2, and that makes sense. Let's just verify that. Oh, sorry, the wrong one. Java C. Let's see, test reservation.java. Just want to show you something. Let's see, when we compile this, do ls. Look here, we have, okay, so we have test reservation.java. That's a file that includes 2 classes, right? This test reservation class and the reservation class. When we compile it, we told Java to compile test reservation. Now, because test reservation has 2 classes in it, and well, because test reservation, well, the point is Java compiled both classes for us, and each class gets put into a separate .class file. That's the main thing I wanted to note here, right? So we have reservation.class and test reservation.class. So even when we have multiple classes in a .java file, when we come to compile, when we ask Java to compile the file, Java will create a separate .class file for each class. So again, we have reservation.class and test reservation.class, 2 separate files. Even though in the .java file we have both classes written together in the same file. Okay, so let's run it. All right, so we see 1 and 2. Okay, good. Now, the thing is, it really doesn't make sense to, well, the thing about this get num reservations method is that we would like to call it before we've created any objects, right? So I would like to say, this is not the print line. I want to call get num reservations and I want it to print 0. How can I call get num reservations? Well, the point is, before I've created any objects, we have 0 reservations. But how do I call getNumReservations? I can't use the name of a reference variable because I haven't made any reference variables yet. I want to be able to call it by just saying the name of the class, meaning reservation.getNumReservations, and I want that to be 0. So in order for this to work, I have to make this method be a static method. Okay, and what a static method means is that it does not have to do with any object in particular. It's a class-wide thing. It tells me some class-wide information instead of something unique to an object, to a particular object. Right. So in other words, reservation.getNumReservations, I'm asking the class, reservation class, how many reservations have been made so far? And initially, the answer is 0. Okay, let's just verify. Sorry, missing the word Java. Okay, so now we see 0 and then 1 and then 2. Okay, now when we have a static method, as you see, we could call it using a reference variable. We could say r1.getNumReservations, and it's going to give us 1 here, and then it's going to give us 2 here because we've created a second object at this point. So that, that works. However, it's considered better style that when we're calling a static method to use the name of the class, like reservation.getNumReservations. Not that. Okay. Just run this again. Be the same thing. Okay, 0, 1, 2. Okay, so that's nice. Now in the reservation class, I would like to have a Twostring method. Okay, so I can print out information about a reservation. So let's do public string Twostring. Now it doesn't make sense for Twostring to be a static method because remember, static means not specific to any object. Okay, but whoops. But in this case, when I call Twostring, I'm always calling it on a particular object. In other words, I want to know the string representation of a particular object. It's not a class-wide thing that I want to know. It's something specific to an object. So it wouldn't make sense to make this static. So public string Twostring, and we'll say return reservation for room, whatever the room is, and then we'll say the day, right, on day plus whatever the day was, day of week. So that will work. Let's go ahead and add this here. Okay, so now I don't really care so much about NumReservations right now. Comment out these lines. Nothing wrong with them, but not so interesting anymore. Okay, so I'll print out r1.Twostring, and I will also print out r2.Twostring. Okay, great. It's clear. Okay, so what do we have? So we have reservation for room 4141I on day 1, right? So that's for R1, and then for R2 we have 1300B on day 3. Now it's not so clear when you're reading this what day 1 is and what day 3 is. Okay, so we would like we would like this class to, instead of saying day of the week as an int, we want it to return, this method should return a string for the actual day of the week, like Monday or Wednesday. So the way we'll make this work is we'll make an array of names of days of week. Okay, so let's make a private. We'll make an array of strings, and we'll call it days, let's say. And we'll put in the days of the week. So okay, that's it. That's our array. And now here, actually I can make it a static field because it's not going to be specific to any object. In fact, every object, doesn't matter what the object is, we still have the same days of the week. I mean, this is just telling us the names of the days of the week. That doesn't depend on any particular object. Now, when I have an object and I want to call its toString method to get a string representation, I want to say the day of the week. Okay, so that, and the way I'm using that is array. So if, let's say, day of week is 0, then I'll want index 0, which is the string Sunday, which makes sense. So I'll have Sunday here. Right? If day of week is 3, that means I want the element at index 3. So this is index 0, index 1, index 2. This is the element at index 3. So I'll get Wednesday, and that's what I'll get right over here. So let's try running that. All right, so we see reservation for room 4141I. That when we created, we said the day of week is 1, representing Monday, and that's what we get here when we call the toString method. And then for R2, we get Wednesdays. That works well. Okay. Now just a little bit more about static. So a static method, sorry, an instance method, right? So what's an instance method? An instance method is like toString. Any method that's not static. Okay, so an instance method can access instance fields, right? Room is an instance field. Day of week is an instance field, so it can access that as well. And it can also access static fields. So days is a static field. If I would want to, this method could access num reservations. Okay, so an instance method can access anything. On the other hand, a static method can only access static fields. So this static method here, get num reservations, can access num reservations. If it wants to, it can also access days, which is also static. But if it tries to say, int x equals day of week, we get a compiler error, okay? Because cannot make a static reference to the non-static field day of week, meaning we are in a static method. So the context here is a static context, and therefore we cannot access any non-static, anything that's non-static. Now, this is only true that we cannot access it directly. But let's say for some strange reason, inside get num reservations, we would create a reservation object. R equals new reservation, whatever, and then we could, if we wanted to, we could say r dot day of week, and that would work, right? Because then we're saying the day of week of r. So we can access this indirectly, but this is very, doing something like this would be pretty uncommon. But the point is, we cannot access day of week directly. We cannot say index equals day of week. Whereas here in an instance method, of course, we can access this day of week field, no problem. Okay, so that's what I have to say about static. Now we can go back to coordinate point. And in coordinate point, I would like to make a field to represent the origin. So, and now I want to make this field be public. Okay, public static final origin. Sorry, what's the type? Okay, the type is going to be coordinate point, and the name of the field is going to be origin, and it's going to be assigned the following: new coordinate point 0, 0. Okay, so what this means is this is a field of this class, and it represents the origin of the coordinate plane, right? Coordinate plane, the center, sort of the origin of the coordinate plane is the point 0, 0. Right, so if I go here to test coordinate point, I could say I can say system.println, coordinate point dot origin dot toString, okay, and that's going to print sorry, let's see, that's coordinate point. Okay, so we have 0, 0 here. So that's what we want. Let's just go through this. The name of the field is origin. This field refers to a new coordinate point object representing 0, 0. The type of the field is coordinate point. It's a final field because I don't want to be able to assign a new value to origin. I don't want to be able to say, let's say here, I don't want to be able to say origin equals new coordinate point, I don't know, 8, 3, right? I don't want this to be able to be done, and in fact, this Java will not let me do it because the final field coordinate point on origin cannot be assigned, meaning once I assign it a value, I cannot reassign a new value. And the reason for that is that I made it final. Okay, great. So that's that public static final. So it's a final field. It's a static field because it does not have to do with any particular object. In other words, when I have, let's say P1, okay, when I have origin, it's not P1's origin. It's not P2's origin. It's not P3's origin. It's not any particular point's origin. It's not, it doesn't pertain to any particular point. It's a class-wide thing. It's a class-wide thing that, for the coordinate point class, what's the origin of the coordinate plane? Answer is 0, 0. It does not matter which object I'm dealing with. So I don't need each object to have a copy of origin. I don't need P1 to have its own copy of the origin field. I don't need P2 to have its own copy of the origin field, and so on. I just need there to be a single field named origin in this class, but it doesn't depend on any particular object, and each object does not need a separate copy of this field. So for this, I will make it be a static field. I'll make it be public. So when you have a field that's final, it's usually okay to make it public. And the idea is anyone who's using the coordinate point class, it's sometimes useful to know what the origin is. So it's useful to be able to say coordinate point dot origin, right? If it would be private, which most fields usually are private, if it would be private, then this line would not work. I could not say coordinate point dot origin because origin is private. I would have to make a method, get origin, which would be fine, but it's a little bit annoying. So I can make it public. And when a field is final, it's typical to make it public. Okay, so now let's see if we can do something a little bit with this. So let's make a method here called public double. So it's going to be an instance method, and we'll call it distance to origin. Okay, so the idea is that if I am here in test coordinate point, I might want to say, you know, what is the distance to the origin from, let's say, P4, right? P4 dot distance to, no, not that, distance to origin, right? So what's the distance? So what is P4 actually? P4 is 10, 10. Okay, so distance from 10 to the origin, which is 0, 0. Right, so of course, I don't really need to have a separate method for this. I could say P4 dot distance to 0, 0, right? That will give me the same result. It's going to tell me the distance from P4 to 0, 0. But it's a little bit more, slightly more convenient to just be able to say distance to origin. Okay, so P4 dot distance to origin. And so I would like to know what that is. So we want to write the method distance to origin. Now, really what we need to do is something basically like this, right? I need to make, so, my first idea would be to copy this code, paste it in here. Now, of course, I have to make some changes. This dot x, so if I say this dot x minus x, what is the value of that? Okay, what is the value going to be of delta x on this line? So unfortunately, it's only going to be 0. It's always going to be 0 here in this method. Why? Because this dot x is the field x, whatever it is. Let's say it's 10. X is also the field x, also indicates the field x, because we don't have a local variable named x. So this would just be 0, which is not correct. Okay, so really, it's really what I want is origin.x, right? So whatever. But the idea is I shouldn't, anytime you're doing copy and pasting of multiple lines, you should think to yourself, can I have one method call another method to do this? Or can I factor this out into a separate method and call that separate method to do it? In other words, you don't want to have to repeat yourself, and it often leads to bugs because you copy and paste code, but then you forget to change the correct parts. So you think it works because you copied code that was working and you pasted it, but really you didn't make the appropriate changes. It's very easy to make mistakes there. So what I would like to do here is, well, I can just say distance to origin dot x and origin dot y. Okay, so so that gives me the distance from this point to the origin, and then I'll simply return that result. Okay, return the distance to, meaning the distance from this point. What is this point? What do I mean by this point? It's the point, it's the coordinate point that P4 refers to, or whatever object is calling the distance to origin method. If I say, P5 dot distance to origin, distance to origin, it's going, then this point will be P5, right? So it depends on which object is currently calling the distance to method. But I mean, sorry, the distance to origin method. But when I say distance to, I mean the distance from this point to the origin. And so it's going to calculate that for me. All right. All right. So it's 14 point something. Verify that. So that here we want the distance from 10 to 0, 0. All right, 14-point stuff, right? Okay, so that looks right. All right, we could do more stuff here. Now let's say we have a coordinate point, and we want to know the x reflection of this coordinate point. Okay, so right, so if we have a point, say here, let's say this point is well, let's try this. How about if we have a point right here? So this is say -3, -2, right? So the x coordinate is -3. The y coordinate is, let's say, -2. And I would like to know the x reflection of this point. What does the x reflection mean? It means the reflection of this point across the x-axis. Okay, this is the x-axis. So I want to reflect this point across. So in other words, I need to go here, right? Okay. So I want the reflection. So how am I getting, what's the reflection? So it's the x value is going to remain the same. It's going to be -3. The y value is going to be the negation of whatever the original y value is. And so -2, -2, which is +2. So I want to have a method that can do this calculation for me. So in other words, right, so if I have a coordinate point P6 equals new coordinate point, let's say -3, -2. And then I say, I want to know that the x reflection. I want to say coordinate point, oops, P7 equals P6 dot x reflection. Okay, so in other words, I want to call the x reflection method on P6, and I want that to return to me a new coordinate point, which I will store in P7. So we can write the method. So public, the return type is coordinate point, and the name of the method is x reflection. So I need to return a new coordinate point. So this new coordinate point is going to have an x value and a y value. So I'll say int new x is going to be, well, it's just going to be the old x. It's just going to be this dot x. And the new y value is simply going to be negative this dot y. In other words, the negation of the y coordinate of the original object. Right, so our original object was -3, -2. So for P7, which is going to be our x reflection, the x coordinate will remain the same, and the y coordinate will be the negation of -2. Okay, so the way we do that is negative this dot y. That's the negation of this dot y. And now I can create a new object. So I can say coordinate point new point equals new coordinate point, and I want to send in to the constructor this new x value and the new y value, and then I can return a reference to this, the reference to this this new coordinate point that I created. Okay, so this is all very nice. I could actually, though, simplify this method and write it in a single line. Simply say return new coordinate point and say this dot x and negative this dot y. Okay, so what does this mean? Well, I don't need to give this a name here, right? In the previous lines, I said coordinate point new points. I gave it a name equals new coordinate point. But I don't actually need to give it a name. I just need to return it. So return new coordinate point. And for the new x, it's just this dot x. For the new y, it's just negative this dot y. So I can just put them in here directly. And that's it. So that's our x reflection method. All right, now let's say I have another idea. I would like to be able to add 2 points together. Okay, so let's say P4 is 10, 10. And well, whatever. Yeah, P4 is 10, 10. Let's say P6 is negative 3, negative 2. So I want to add these 2 points together. So I want to be able to say coordinate point P8. That's going to be a new coordinate point, which is going to be it's just going to be P4 plus I don't know, P6. Let's say. Okay. So in other words, let's see. So P4 we said is 10, 10. So we want to know what is 10, 10 plus. Then we have P6, which is negative 3 comma negative 2. So negative 3 or negative 2. So the result should be, well, 10 plus negative 3 is going to be 7. And 10 plus negative 2 is going to be 2. Sorry, it's not going to, sorry, it's going to be 8. Okay, so that's what I want. So that's what I want P8 to represent. So when I print out P8 dot toString, I wanted to say 7, 8. So how can I make this happen? So I need to add a method here. So public. So what this method returns is a coordinate point, right? So coordinate point plus, that's the name of the method, and then we have the parameter coordinate point other. Now remember, when in this method we want to add 2 points together. Where are the 2 points? So 1 point is this parameter here, other, and that's what we have P6 for, right? That's other, that's the parameter. But where's P4? Where's P4 in the method, right? Well, the answer is it's this, right? So this refers to the object that P4 refers to. Okay, so how am I going to add these 2 points up? So, well, I'm going to need to create a new coordinate point object. So coordinate point new point equals new coordinate point. But what should I assign for the x value and the y value? Let's see. So let's work it out separately. So int x, let's say new x, what's that going to be? Well, it's going to be this dot x plus other dot x. And then int new y is going to be this dot y plus other dot y. Now I can put in new x and new y in here. Okay, and then I can simply return this new point that I created. Okay, of course I can do this in one line. So let's do that. So return new coordinate point, and sending in for new x, I'll say this dot x plus other dot x. Okay, now for the second parameter, I will say this dot y plus other dot y. Okay, great. And that should work. Let's just test this. All right, so we get 7, 8, which is correct. That's what we expected here. Okay, let's just write one more method here in this class. So let's say we want to be able to again find the sum of 2 points. We want to add 2 points together, but let me show you how we might want to do it in a different way, right? So we might want to say instead, let's say PA should be assigned the sum, CoordinatePoint.sum of P4 comma P6, right? So it's just a different syntax to do the same thing. Here we are saying P4 dot plus P6. Here we're saying CoordinatePoint.sum of P4 comma P6. Here again, here of course sum is going to have to be a static method. I'm calling it using the name of the class. So let's write that method. So public static returns a coordinate point. The name of the method is sum. It has 2 parameters. Coordinate point, let's say P1, and coordinate point, let's call it P2. Okay, so of course, in a static method, there is no this field. Oh, sorry, there is no this reference. I can't say this.x. There is no this in a static method. I only have the parameters that I passed in this case, P4 and P6. So how am I going to do this? Well, it's going to be the same kind of idea as before. Return new coordinate point, and for the x value of the new point, it's going to be P1.x plus P2.x, and then for the y coordinate, it's going to be P1.y plus P2.y. Okay, let's test that. All right, so hold on. Oh, I didn't print it out. Let me print it out. That was the original. So first I did it the first way and I printed it out. Now I'm doing it the second way. Let me print it out again. All right, and we see it's also 7,8, so that's good. Okay, very good. Let me just show you maybe actually maybe one other thing I could do here. In the plus method, let me show you. Now that I have this separate method here, I could say return this dot. Sorry, no. I can say return the sum of this comma other. See that? So I can eliminate a tiny bit of code duplication, right? This line here is doing basically the same thing as this line here, which is fine. But if I want to be really concise, I can say just return the sum of this comma other. So this will be passed to P1, other will be passed to P2, and then this static method will create a new coordinate point and return it, and then this method will return it. Let me just test this again. Okay, it still works. So this is just a little cool point, a little cool thing I could do. Okay, let's take a short break and then we'll continue. All right, so now I would like to make a new class named circle. Okay, and every object of this circle class will represent a circle. Now, what does a circle have? Well, a circle has a location and it has a radius. So for the location, we'll say coordinate point location. I'll make it a private field. Okay, and that, and then we will do private int, or maybe double. For the radius. Okay. All right, so now, well, how are we going to do this? So first of all, the first thing to note is we're using composition, also known as aggregation, and that's where an object has inside of it a reference to another object. So every circle, again, this is a template. This class provides a template for circle objects. So every circle object will have inside of it a radius, which is a double, and a location, which is a coordinate point. So inside every circle object, there is a reference to a coordinate point object. That's what we call composition. It also sometimes call it aggregation. Okay, so we can do a test circle. Main method, and so we can say circle C1 equals new and now we need to specify the location of the circle. Well, we want to specify the location, so let's make a coordinate point, call it location or something, whatever we want, and let's say it's new coordinate point, say 7, 3. Oops. And then I can, when I'm creating the circle, I want to specify the location and the radius. Let's say the radius is 5.5. Okay, so how? Well, of course, it's not going to work yet because I didn't write a constructor here in the circle class for that. So public circle. It's going to take a coordinate point named location. It's going to take a double for the radius, and as usual, it's going to say this dot location, be assigned the location, and this dot radius is going to be assigned the radius field. Sorry, the radius parameter. So the field is going to be assigned the value of the parameter. All right, so now we'd like to have a Twostring method as well, so we can print it out. So write it. So we'll say something like return, something like circle at whatever the location is. So we'll say the location dot Twostring. Here we're calling the Twostring method of coordinate point, right? Again, we're in the circle class, in the Twostring method of the circle class, and inside this Twostring method, we would like to call a different Twostring method of the coordinate point class. And we can do this simply by saying location.Twostring, and that's going to work because location is a coordinate point. So Java knows to call the Twostring method of the coordinate point class. Okay, so that's going to tell us the location of the circle, and we'll say with radius and whatever the radius is. All right, so now if I go ahead and try to print out C1 dot Twostring. Okay, that should give me the information about the circle. So let's try that. Okay, let's just for fun, let us do rm star.class. That will delete every .class file in the current folder, current directory. If I do ls, you see we only have .java files, right? All the class files are gone. Now I'm going to tell Java to compile test circle. Okay, now test circle relies on circle, so circle will also be excuse me, will also be compiled. Test circle also relies on coordinate point, so coordinate point will also be compiled. So let's see that. Okay, so we see that we have in our, let me do ls star.class. Just want to list out the .class files. So I have my .class files are testcircle.class, CoordinatePoint.class, and circle.class. All right, let's run it. Java test circle. Okay, circle at 7,3 with the radius 5.5. So that's exactly what we wanted. Okay. Now there are some issues here because let's say I go ahead and say this circle C2 equals new circle. So I'm calling the new circle, calling the constructor, and I need to pass in two things. I need to pass in, as I see here, a coordinate point location and a double for the radius. So what happens if I go ahead and I pass in null as the location coordinate point, and let's say 9.7. Okay, so the compiler won't stop me. It will run. It will compile. It will first compile, and if I try running it, it will run. But I might have an issue. Let's see what happens here. Let's see. Let's just do Java C, test circle, Java, and run it. Right, seems to be fine. Let me try printing it out. Let's just say C2.toString. Whoa, what do I have? What happened now? Exception in thread main, java.ling.null pointer exception. Cannot invoke coordinate point.toString because this .location is null. What's going on here? So on line 7, I'm creating a circle C2, and the location is supposed to be a coordinate point. But remember, when I'm dealing with a reference variable, it could either refer to an object or it could have the value of null. So in this case, let's say it has the value of null. If you want to, I can even say this. I could do it like this. I could say location is equal to null, and I could put in the location in here. It's same problem. Whoops. Same issue is going to happen. The point is I'm passing null to the constructor. Now that's fine, right? Again, without line 10, no issues. I mean, nothing will get printed for the second circle because I never told Java to print it. But I won't get a null pointer exception. Let me just show you. Run it again. No, I don't have any null pointer exceptions. Right. So again, the constructor will say, okay, fine. You want this parameter is null. Fine, I'll assign it to this .location. No problem. So this .location has the value of null. So now for this new circle, right, for C2, the location field has a value of null. Okay, fine. But now what happens when we say C2.toString? So we're going to go here to this Twostring method. So we're going to create a string circle at, and then we're calling location.toString. Now for C1, when I say C1.toString and I do location.toString, well, that's going to tell me the location, and that's going to be, in this case, 7,3. But for C2, when I call the Twostring method for C2, what is location.toString? Well, for C2, location is null. So if I try to say location.toString, that's not legal. We get a null pointer exception. You cannot use a null reference to call an instance method, right? So location is a reference. It's a field of this class, but it also happens to be a reference variable. And if it has a value of null, we cannot use it to call an instance method like toString. Right. So this is obviously not desirable. We don't. So of course, again, we don't want to have null pointer exceptions while our program is running, because when we get an exception, we get this message and then the program stops. So that's not very useful, right? If I have anything later here, anything later will not run. Show you. See, hello does not get printed because once we get the exception, it's Java stops the program. Actually, later on in the course, we'll see that we can actually recover from exceptions and ensure that the program doesn't stop. But still, the default is that the program halts, and this is not desirable, obviously. Okay, so the point is, now on the other hand, we can't prevent the user from passing in null into the constructor, right? Again, the constructor takes a coordinate point location. So if you're a coordinate point, you could be null, right? If you have a variable that is a coordinate point, it's legal for its value to be null. There's nothing you can do about it. It is legal. Java allows, and pretty much every language allows a reference variable to have a value of null. So what are we going to do? So what we'll do is we'll test the value of this location when the user passes it in. So we'll say if this dot location, sorry, not if this dot location, if the parameter location is equal to null, then I want to say this dot location should be, well, I don't want it to be null, right? So I don't want to say this dot location equals location because that would make it null. I want it to be, well, I don't know. The user didn't, I'm going to treat it like a case where the user doesn't specify the location. And in that case, I'll just say the location is the origin. So I'll just say coordinate point dot origin. Okay. And that seems like a good idea. And then otherwise, I will say this dot location equals location. Right. So if the location parameter is not null, then I could take location and assign it to the field. So, and then of course for radius, I don't have to worry because radius is a primitive variable, so it's never going to be null. Okay, so that seems good. Let's test this. Whoops, let's test it now. All right, so now for the second circle for C2, for which I passed in null as the location, you see that circle class has given it a default value of 0, 0. So good, very good. Now there's another issue. For radius, right? It's technically possible that the user will pass in a negative value for the radius. They might say negative 9.7. Now I want to prevent this from happening because, it doesn't really make sense to have a circle with a negative radius. But there's nothing I could really do to prevent the user from passing in negative 9.7. Actually, later on, we'll see how we can actually prevent this. But as far as we know, the user can pass in a negative number. It's a double. The parameter of this constructor is a double. Doubles include negative values. It's a legal, it's a legal value. Negative 9.7 is a legal value for a double. So what can we do about it? So what we're going to do here is we're going to say, okay, we're going to test if the radius that the user gives me in the parameter is less than 0, then I don't want to say this dot radius equals radius because that's going to assign a negative value as the radius, and I'd rather avoid that. So what am I going to do? Well, I have a few different options. One is I can say this dot radius, and maybe I do the absolute value. Maybe I'll say this dot radius equals math dot absolute value of the radius that the user provided. So that's one option. Just make it positive. Okay, but another option maybe is just to make it 0, and that's what I'll do. So this dot radius is 0. Okay, so if radius is less than 0, then this dot radius is assigned 0. Else, we'll say this dot radius equals radius. Okay, so that's what we'll do. So let's check that out. So compile and run. All right, so now we see circle at 0, 0, and with a radius of 0.0. Instead of a negative 9.7, it's going to be 0, 0. Let me just show you something. Let's say I made this field public instead of private, right? And it's legal to do that. I'm allowed to make fields public, totally legal. But now look what I could do. I could say C2 dot radius equals -9.7, and there's no way to prevent that. There's nothing I can do. And if I go ahead and print out C2 dot toString, it's going to print negative radius, -9.7. Right now, so I want to prevent the user from doing things like this. In other words, anyone who's using my circle class, right? I want to prevent them from being able to assign a negative radius. But if radius is public, there's no way I could prevent that, right? Because the user of my class could just say C2.radius equals 9.7. Okay, so that's one reason we make fields. That's one reason that we make fields private, so that now if I say C2.radius, the compiler prevents the user from doing this. It says the field circle.radius is not visible, so I cannot. The user cannot do this. Okay, great. All right. What else should we do? Well, we can make a copy constructor, perhaps. But actually, before that, let's make some getters. Let's make a public. So let's make a get location method. Okay, get location. Okay, let the IDE do it for me. So public CoordinatePoint get location just returns the location. That seems pretty straightforward. How about get radius? Okay, public double get radius, return radius. Okay, so now if I have a circle, I could say system.out.println line. Let's say C2, whatever, C1 dot get location. Oops. Get location dot toString. Right, so that means get the location of circle C1, which is a coordinate point, and then call toString on that coordinate point. Right, so this is going to be the location of C1. Okay, let's try that. Location of C1 is 7,3. Okay, pretty good. Now I could do something else. I could say, well, I could say coordinate point. I don't know, P equals. Let me do this. C1.get location, and then let me say P.toString. Move this line up. All right. Okay, so coordinate point P equals C1.get location, and then location of C1 is P.toString, so that should be exactly as before. Right, so 7,3. Okay, very good. Now, what if I say this? What if I say P dot, so P is a coordinate point, so it has a method named setLocation, and let's say I set the location to be, I don't know, 5,5. Okay. Now, what do you think is going to happen when I print out? Well, let's say I go ahead and print out C1. C1. Well, okay, this is actually, let me try something else. Let's say we make a, well, let's talk about copy constructors. Let's talk about copy constructors. Let's say we want to make a copy of a circle. Okay, so we have let's say we have C1 and we want to make a copy of it. Okay, so we have coordinate point, let's say when we have C3 equals new coordinate point, that's a copy of C1. Okay, great. Now, so of course we need to write this copy constructor. So we'll write it. Public circle. Sorry, no, not new coordinate. Sorry, new circle. What am I saying? New circle. Okay. So again, I want to create a new circle. A new circle named C3, and it should be a copy of C1. So I'm writing a new constructor in the circle class to do this for me. So here I have circle, and this is the original circle. And then here I want to make a copy, right? So I want to initialize the new circle to be a copy of the old circle. So I'll say this dot location is equal to original dot location, right? So it's going to be a new object, but the contents of the new object will just be a copy of whatever was the contents of the old object, right? So this dot radius, this dot radius is going to be original dot radius. Okay, now test circle. So now let's say I have this, right? So I have P, and P tells me the location of C1. P is C1.get location and location of C1. But actually, well, let's first print these out. So let's first go ahead and do s out and print out C1. And then let's do the same thing for C2, for C3, which is our copy. Okay. All right, now suppose we go ahead and don't need these lines anymore. So suppose I go ahead and I say C1.get location. So what is that going to give me? That's giving me a coordinate point. And I say set location of that coordinate point to be 5, 5. So that's going to update the location of C1. It's going to give it a new location. Instead of 7, 3, it's going to be 5, 5. Now, we don't want this to affect C3, because after all, C3 is a new circle object, which is an independent copy of C1. But if we change C1, it shouldn't have any effect on C3. But let's go ahead and print out, again, C1 and C3. I'll say now C1 is, and now C3 is. All right, so we see C1 is a circle at 7, 3 with radius 5, 5. So initially they're the same, and that's right because the C3 is a copy of C1. Now I modified the location of C1, but notice that had an effect on C3. But that shouldn't be happening. After all, C3 is a completely new object. It's a completely new object. Well, here's the problem. Problem is that what's happening, the situation I have here is that C1 is, as usual, a variable, and it refers to a circle object. And in this circle object, there is a location field, and there's a radius field. Okay. Now, the radius is, what is the radius? Whatever, 5.5. Okay, now location is not a primitive value, it's a reference value. So it refers to a separate location object, sorry, a separate coordinate point object, which has an X and a Y. Okay, now when I make a copy of C1 and I have C3, that's the reference to the copy. So C3 refers to a completely separate circle object. Okay, but this circle object also has a location and a radius. Now the location, because of the way we wrote the copy constructor in the circle class, the location does not refer to a completely separate object. rather, it refers to the same object that C1's location refers to. So therefore, if I modify C1's location, that also has an effect on C3's location because they both refer to the same object. And the reason for this, again, this is not ideal, but the reason for this is the way I wrote the copy constructor in Circle. Right? So what did I say? I said this.location equals original.location. So I'm just making a reference copy of original.location. Original.location is a reference that refers to a coordinate point object. What I'm doing here on line 20 here is I'm making a copy of that reference, but I'm not creating a new object for my new circle. It's the same coordinate point object. So that's why if I modify the location of one, it has an effect on the other, which is not ideal. So what I want to do is I want this new circle to have a completely new a new coordinate point object for the location. And the way I'll do that is I'll say new coordinate point and pass in original.location. So what I'm doing here is I'm calling the copy constructor of the coordinate point class. Okay, so now going back here, oops. Right, so now when we modified C1, that had an effect on C1. So the location is now 5, 5. But for C3, the location is still 7, 3. So that's good. So what we're doing, this is called deep copy, right? So we're making a deep copy of the circle. Before we were making a shallow copy, which isn't good when you have a reference variable as one of the fields. Now for a radius, we don't have to worry because radius is a primitive variable. So there's no need to, well, it wouldn't even be possible to create a new object. It's just, we can just make a copy of the value and this is a separate copy. But for the reference value, the reference variable like this location, we should make a deep copy as we are doing here. Okay, great. So that's well, of course, there's more we could do with circle. We could have a method, let's say, for getting the area of a circle. So let's say how do we get the area of the circle? So we'll have a method public double get area. Okay, so how do we find the area of the circle? Well, the area of the circle depends on the radius, right? So it's the area of the circle is math.pi. It's pi r squared, right? So math.pi times r squared, the radius squared. So that's, and then I'll just return this result. Okay, so of course we can have other things. How about this? How about if we want to write a method public public boolean, it's going to return true or false, and I would like to know whether this circle contains a certain coordinate point. Okay, let's say P. So does this circle, whatever circle it is that I'm calling this method on, does that circle contain this specific point in it? In other words, is the point contained within the circle? So show you. So like, for example, let's say we have a circle that is, let's say centered at, let's say the center is at 1, 1, and the radius is, let's say 2. Okay, so the radius is, let's say 2. And I have a point, let's say right over here, which is, say, 1, 3. So this point is contained inside the circle. On the other hand, if I have a point like 1, 5, that would not be contained inside the circle, right? So I want to have a way of telling whether a point is contained inside my circle. All right, so how are we going to be able to do this? So here's the trick. Here's the trick. Well, of course, this trick won't work in all cases. This trick wouldn't work for a rectangle, let's say. if I want to know is a point contained within a rectangle, this trick might not work there. But for circles, we could use the following trick. So what we can do is say, tell me the distance between the location of the circle, meaning the center of the circle, and this other point, right? What's that distance there? If the distance is less than the radius, then the point must be inside the circle. But let's say I have this point right here, right? So I find, okay, the distance from the center of the circle to that other point is greater than 2. So then I know that that other point is not inside the circle. Okay, so the trick is I'm going to find the distance from the center of the circle to whatever point I'm interested in, and then see if that distance is less than the radius. If it is, then I'll consider the point to be inside the circle. Okay, so what else? Now, of course, how do I find the distance from the center of the circle to another point? Well, we have a method in CoordinatePoint that does that for me. So I can say location. So location, remember, is the center of the circle, dot distance to, and then I can say p.x and p.y. So that tells me the distance from location to this point. Now I want to know, is that location less than the radius? And I want to return that result. Okay, so again, I can't say p.x. Why can't I say p.x? Because x is private in CoordinatePoint, and right now I'm not in CoordinatePoint class, so I have to say get x. Okay, and I can't say y either. I have to say get y. Okay, good. Now, location at distance to p.get x, p.get y. That's a number. That's a double. Less than radius. This whole thing that's highlighted here is a Boolean expression. It's something that's either true or false. And depending if it's true, the method will return true. Otherwise, the method will return false. Okay, so this method will do that. Now, let's say we didn't do this in class, but let's say I want to do well. Okay, maybe we'll do it next time. Anyways, there's more we did in class. This is not everything we did in class last week, but this is the main points. So if you have questions, I'm willing to take them.